Hello, my name is Jalen Toston. I am in mechatronics lecture class with Dr. Ishmael, and this is for Project 4, and I will be demonstrating the code that is used for the program for the servos. So in this video, I will be exploring and also showing how to determine the joint angles that is needed for the robotic manipulators and effectors to reach the specific X and Y coordinates. We will be using these graphical methods that will also be used to calculate and require joint variables for 2 different end effector positions. Also, we will verify these results using simulation software as demonstrated in the link tutorial from the documentation from our Canvas website. This practical approach helps visualize how each joint influences the manipulator's overall positions in 3D space making, and also making it easier to understand robotic movements and control. So I will now translate over to the code that is used right here. And I'll just mainly go through and break down the sections as well. So at the top here, you can see that this says includes Project H and also math as well. That will allow us to import essential libraries from Project H. That's like the various other codes that we would have to use. Like if we had to use a certain one from like an old code that we use in different projects, it will be able to read that code and implement it into this specific program. And also that be the math.h, that just imports like math and like certain functions and equations that we use in the program as well. So going down here, this part here states for the theta 1 float angle and also the theta 2 float angle, as you can see right here. That's gonna allow us to convert angles into degrees and using the PWM signals for the servos, which essentially allows them to be able to move in which direction, like how far we want them to turn, which directions, or whatever the case may be in that moment, whatever we choose to design them as well. So also here, for the float part, we will be using linear mapping between minimum and maximum angles to correspond to different PWM signals. And that also is going to allow us to use the compare function as well, which will compare PWM values that's based on the angles that we are given or that we use for our servos. So that just essentially means like, okay, so we'll run the program, see how the servos move, and if we don't like it, we can go back and change those values as well. Getting down to also the main functions for the XY portion, showing right here. These are also our equations as well. The XY represents the desired end effector coordinates, mainly in centimeters, and also for the A2, like the A4 values that you see here where the cursor is, that's like denoting the links for the manipulator arms. And also displaying like the angle distances, like using the R1. Let me see if I can find it right here in the code right there for the R1. That's calculating the straight line distance to the end effector positions. And also here, let me see if I can find it, the phi 1 through 2 and also 3. Those are intermediate angles, which are derived from the geometry of the arms. Scroll down a little bit more here. Wait, where did we put in for our T1 and also our T2 right here being shown? These are the main joint angles that are derived from calculus angles, and that's also going to be used to achieve the end effector position as well. Meaning is like whenever the servos move, which points it's going to stop at, or how far do we want it to move, the rotation aspect of the servos as well. And when we get to the bottom here, this is the PWM setup, which is also to control the servo motors. I'll display that and just show what the servo build and like what the servos are as well. And the servo control loop with the PWM right compare 1 and right compare 2 as well. That just sends the T1 and T2 values and showing like, okay, we need this servo to move this way and the second servo has to move this way. So it's just allowing us to determine or like how far and which directions we want those servos to move for the project. And we also have our delay aspect for the servos at the bottom here. You can see that right there, the delay 2000. That's basically just implying that there's a 2-second delay in order to let each individual servo move, depending on what's going on. But you can change this, but that's what the designated values were from the video that were displayed from our Canvas website that we used. And here, this is our PSOC, and this is our cord that we use in order to transfer the program to the PSOC. This is our breadboard here. These are our wires, our connections. This is the output that we use to get power for the servos to move. And here are the servos, servo 1, servo 2. These are the links. This is our pin. That just basically just is gonna map out like the lines, but our marker ran out. And basically, this is the part right here that we use in order to make sure that our program gets transported over to our PSOC and our program runs.
Total honesty between us. No secrets.
I 100% agree.
So here's the secret to start off. There is no guy with a thing.
I was beginning to wonder about him.